Here we shown the topic of programming data structures and algorithms. It is one of the important topic in GATE exam. Here these are the table of contents we have. Let we start. Uh, Data types and mutability. Let me explain simple. Int, float, string, tuple, list, dictionary, set. These are the data types, right? So in these data types, let me include that the gate focus is where it depends on mutability, output prediction, and scope. Okay. So first, you know very well data type and what is meant by mutability. Mutability means the changeable value. For example, I write as a t is equal to 4. Okay. The immutable means the value cannot be changed. It means if we initialize the value is 4, we can't change this 4 value. So it means it we can't change int, float, string, tuple. These in these objects we can't change the value of the after initializing. That we called immutable. The note point is the changing a variable points to a new object. It means we can change this t value at this position, but we can't change this 4 value. The mutable means change in place. It means we can change this value of 4 at this point. Okay. So the list, dictionary, and set. So these are the notable means it is changeable options. We know pop, append, and di- uh, something push. That items will be happened here. It helps to change in place. But in your immutable, we can't change any values. We can change object only new as a new object. It means, for example, t is equal to 4. It means we can change a equal to 4. Like that way, we need change. That way he said that this is immutable and this is immutable. Next, here one of the important topic in programming and data structures. So you are observe that syntax list, start, stop, step. Start means starting element here, and a stop means the stop element must be excluded in the list. And a step means we need to flow up that step value. For example, if we 2, then we step with that 2 times. Next, a simple example, right? Is another point is the negative step reverse the list. If put the -1, it will helps to reverse the list. So here the simple example is a is equal to 0, 1, 2, 3, 4, 5. So in this given list, you need to observe that index value is 0, 1, 2, 3, and 4. Okay. It means 1 is to 4, right? So it definitely starts with 1. Okay. Because this is a starting element. So 1, 2, 3. The the second means stop element. We can't include this. This is a stop is an exclusive term, right? So that's why mm, 0, 1, 2, 3, 4 is the correct answer. But we will start with 1, then 1, 2, 3, 4. So the fourth element is a stop inside. That why we can't include it stop. The answer will be 1, 2, 3. Okay. Next, print A of column -1. So it means it is a step element. The step elements if negative, it, it helps to reverse the list. So that's why it will happen here. It helps to reverse the list. 5, 4, 3, 2, 1, 0 is happened here. Next, print A of -2 is to some empty. So how to solve this problem? First, the -2 means here you observe that first in this statement the -2 is 4, right? We need to end up with the string because it is reversible. So after reversing that, the second element is uh, here 4. In this 4, the remaining element means the 4 and 5. It means it is minus in the ending it is the minus 1 value and it is the minus 2. That way it will start. So it means the minus 2 value is 4. It is the starting element. So that's why we included the minus 2. And the empty is there is nothing is available. That's why so minus 2 minus 1 is the answer. So the 4 and 5 is the answer. That's why we included that term. Next, dictionaries and recursion. Dictionary, we know that a key and value pairs. The key and value pairs we called as a dictionary. Keys must be immutable. It means we can change the keys. Okay, lists cannot be keys. It means the lists cannot be keys. You need to remember these points very well. Lookups are of one on average. So this is that a complexity of by looking up the time. Recursion and scope. Variables inside functions are local unless marked globally. The recursion and scope means uh, the variables inside functions are nothing but local unless we mark global. If we put that scope value is global, then it is available for all complete program. If it is local statement, there is unless there is no marking for the global. It is used for local purposes only. The gate tip is always trace recursion trace carefully. It means in the GATE 2024 exam, the question 63, they asked that the recursion tree is careful. The tracing is available for the recursion tree. It is very important. He is saying the time and space complexity. The notations are here. We observe that the big O is an upper bound. It is the that we said this is called as worst case, and omega. This is the symbol for the omega. It is for the lower bound for best case. So you need to remember these three scales. In these three scales, the the worst case is big O. The average case is this one, and the omega case is this one. So it will be low to high. So you need to remember that as a low to high positions. So theta, the first let we state that um, in the bounds there will be different. So the boundings are vice versa, but in the cases you need to follow this rule. Uh, Worst case uh, uh, theta as a average case, worst case, average case, and the best case. So it means big O, theta, omega. Next, Master theorem. The Master theorem, the formula is here. This is the formula for the Master's theorem. T of n is equal to a into T of n by b plus f of n. For the comparison of this master theorem, we need to follow these two conditions to compare that n power log ba versus f of n. If f of n is this value, then omega of it means big O of n power log b a minus epsilon, then the t of n value becomes theta. So if you observe that the t of n value is completely theta values, but in the root values n power log b a power minus, these are the different values, but the t of n values must be in the theta initially. It means if you there is a chance to get this any question on this based on the gate exam. Merge sort. For the merge sort, the t of n is equal to 2 into t of n by 2 plus n. The theta value theta of n log n. This is the complexity. For binary search, the complexity is O of log n. Here the stack follows last in first out principle, and these operations are push pop. It followed that O of n linear complexity is possible at this point. It uses balancing parenthesis problems and a DFS recursion problems we use in the stack we use in these cases. Next, queue follows first in first out rule. Its operations are NQ, DQ, and linear complexity. It is used for BFS and scheduling problems. You need to remember that point. Stack is used for DFS and queue is used for BFS. Right? Next, linked lists. So in the linked lists, uh, the axis is O of n. It is the complexity of O of log n, O of n, big O of n. Insert by delete at head, it takes O of one complexity. Insert by delete at tail, it takes O of n. That's why we take that the average will be O of n as the complexity ratio for the linked lists. Binary tree properties. In the binary tree properties, we have some important points. You need to remember this one. Maximum nodes at level k is equal to 2 power k. This is the formula for the maximum nodes. Maximum nodes in the tree of height h is equal to 2 power h plus 1 minus 1. This is the another point. And the handshake lemma. It is the one of the strict binary tree. The formula is L is equal to I plus 1. The leave nodes is equal to internal loads plus 1. It is the handshake lemma. This is also one important point. The tree construction uniqueness. So first you need to remember at these points. The first point is the self has there is no uniqueness. Okay, there is no unique will be drawn. For example, in order plus in order we can't draw, and post pre-order plus post pre-order we can't draw the unique tree, and post order plus post order we can't draw the unique tree. Similarly, without in order, we can't draw uniqueness. For example, pre-order plus post-order not sufficient. So it means there is we can't draw at this point also. So these are the one point and these are the second point. So the main cases are in order plus pre-order or in order plus post-order. At these cases, you need to construct the reconstruction. Next. So here this is the binary search tree. Left child less than root less than right child. It means this is the first this is the path we need to go that left root right. This is the increasing order we followed. The average case is O of log n. For the worst case it happened that O of n. For the binary search tree. The balanced binary search tree, the guaranteed height is O of log n and the worst case is O of log n. Here the hashing concept. In this hashing concept, the alpha value indicates the number of elements by table size. So this is the formula for the alpha. Chaining. So collision resolution. We need to resolve the collision resolution by following that open addressing as a linear probing and quadratic probing methods. These are the formulas for the linear probing and quadratic probing. And these are the searching algorithms. We know that linear search and binary search. The best cases are O of 1 for the linear and binary. And the worst case for the linear search is O of n. And this is used for the unsorted data. And binary search is used for the sorted data only. Here this is the search recurrence formula. T of n is equal to T of n by 2 plus 1. Next. The sorting comparison. This table is very important for definitely a question will be happened in the gate exam. So bubble, the best case is bubble sort. The best case is O of n. The average case is O of n square. The worst case is O of n square. You need to remember this table very well. Then definitely a question will be happened here. You need to remember some important points also. For the selection sort, the all case, the best and average case must be same, but it is not stable, right? You need to remember this point. Next, for the merge sort also, n log n and average case, worst case also same, but it is stable. So this is the difference between selection sort and merge sort. You need to remember this point. And And the another point is for the quick sort, best case and average case become same. The worst case is O of n square. So the space is O of log n. There is no stable. So these are the selection sort and quick sort. These two are no stable, and for the merge sort is stable, i- and it is the same for the best and average and worst case for all scenarios. The insertion sort best for nearly sorted arrays. For n, if n value is less than 50, it is used for, if we use it best for nearly sorted arrays. For the quicksort, the worst case can be brought and smallest by largest. You need to remember this point also. BFS, it is nothing but breadth first search, but DFS is nothing but depth first search. It is used for the queue and it is used for a stack. Finds shortest path in unweighted graphs. It is helps to find the shortest path. In the real time we tell that Google Maps, right? In Google Maps, the we need to find the shortest path location. That in that cases, this algorithm will be helpful. The time complexity is of vertex minus edges, vertex plus edges, vertex plus edges. We have the graph, right? These are the vertices, and these are the for example, this is the gap, and these are the vertices, and these are the edges. One, two, three. At that point, we said so that the time complexity becomes vertices plus edges. Next, the shortest path algorithms. Here, these are the shortest path algorithms. In this shortest path and Dishkrista's algorithm, it followed that greedy approach and works on negative weights. And these are the E log O of E log V. This is the time complexity it is using for the priority queue and Belmont FUD. It is used for dynamic programming. In some cases, there is a chance to ask a single question based on this slide. Works with negative edge weights. The Bellman-Ford main conditions rules is dynamic programming works with negative edge weights and can detect negative edge cycles and the time complexity of vertices into edges. These are the problem solving tricks. It is helpful for the solving some problems. Sorting swaps. Insertion sort swaps is equal to number of inversions. Selection sort is equal to minimum swaps of n. Recursive tracing, don't guess draw stack frames. It means you need to draw some stack frames, then you got this recursive tracing. Hashing method, check collisions manually using modulo arithmetic. In the hashing, we have the formula, right? H of modulus. The you need to apply that in this hashing math. Then you solve the problems. Next, here the example of the hashing is hash table size 10. H of x is equal to 3x modulus 10. This is the formula for the hashing. The linear programming we need to apply. Insert 1, 4, 15. So we need to apply this into this formula. Then we got that the storing the slot 3, slot 2, and slot 4. These are the storing places, indexes in that hash table. So that's for today. Uh, you need to remember these all points today very well. And if you are observe that programming data structures and algorithm. This is very important for the some entrance exams also. You need to remember this very well. And thank you everyone.